We're going to look at Unit 1, Lesson 0, but Unit 1 is basically all about how chemicals bond together. So we're going to talk about, like I said, chemical bonding, how things bond together. We're going to look at things like melting and boiling points, molecular compounds, ionic, and all that other stuff. The first few lessons will be a little bit of review, but we will add on some new stuff for you. So you will see some Science 10 stuff here for sure, and that's fine, but we'll probably add on to it as well, hopefully for you, so it won't be too repetitive for you. You guys will have some notes to take here, so I'll let you go ahead and copy down some stuff here. All right, so physical change. Physical change is just a change in matter, for example, or structure where there's no new substance being formed. So melting an ice cube, breaking a pane of glass, ripping a sheet of paper, maybe different form, but doesn't produce anything new for you. A chemical change does produce something new. So when you mix two things together, you're going to get a reaction, for example, and a new substance will be formed. So if you took calcium and you mix it with some oxygen in the air, you'll get some calcium oxide, for example. If you burn a piece of paper, or if you look at the rusting of metal, that is a process that is forming something new, so that is a chemical change. How do you know if a chemical change has taken place? Well, there's clues that indicate a chemical change taking place. There's 4 of them that we have up here for you, okay? So the products, of course, will always be different than the reactants, and that's another thing to know there. All right, so let's copy those down. Okay, so clues that chemical change has taken place. Energy in the form of heat or light is either absorbed or released. So when you mix two chemicals together, sometimes it'll need energy for that reaction to take place. So things will get colder, like ice packs, for example. Will take energy from the surroundings and cool itself down. That's what you'd see there. In some cases, when you burn stuff, of course, combustion reactions, you're producing heat. You're going to get some heat out of that, so it's an exothermic reaction. So it is released in that case. We'll talk about endo and exothermic later on. Color change takes place. A new solid known as a precipitate will be formed, and of course a new gas is produced. And in a solution, gases, you're going to see them in the form of bubbles, of course. So we'll see that throughout the course of this year here. All right. 2 types of observations. You can either see a qualitative observation. So we're talking about qualities. When you look at somebody, what qualities do you see? Okay. So we talk about changes in color, odor, physical states. Those are things you can see, all right? Quantitative observations, which is mostly going to be Unit 4 for us, is how much. How much do we expect to get? How much, what's the mass going to be of this product? Or how much do I need to use to make this much? So that's a quantitative observation. Classification of matter. All matter is made up of atoms. The different types of atoms that exist are known as elements. And of course, you can find these on the periodic table. Tomorrow I'll get you your periodic tables. And we'll talk, obviously, a little bit more about that as the coming days here. And so forth. Okay. So here we see matter is broken down into pure substances and mixtures. Pure substances contain elements and compounds. Mixtures are mechanical mixtures and solutions. So we'll go on and define a few of those right now here as we move along here. So pure substance, of course, all the particles are identical within. Mixture, there are different types of particles within. And we'll go ahead and define element. So what is an element? It's a pure substance made up of only one type of atom. So just going back up here for a second. Elements are pure substances made up of only one type of atom, like I said. Each element has its unique set of properties, and that's why, of course, carbon's different than nitrogen or oxygen or phosphorus for that matter. Elements cannot be broken down by chemical means, so you can't take some carbon and heat it up and decompose it anymore. It's just still going to be carbon. They can be broken apart by nuclear reactions. I think maybe we'll just stick with chemical reactions in this class, if that's okay. Otherwise, we're going to take nuclear chemistry and jumping ahead a little bit for some of you, just for some. Holy. Elements cannot be, most elements exist as individual atoms, and what that means is like, hey, I'm walking down the street. This is funny now, don't get ready to laugh. I'm walking down the street and I say, hey, look, it's aluminum atom, right there. I see them. So you'd find one atom by itself, okay? If you're walking down the street and say, hey, it's aluminum atom, you could find one by itself. You're walking down the street and you see some magnesium, and you're like, hey, look, it's magnesium atom. But some, okay, exist only as molecules. So what that means is, and what we call them is the molecular elements. You guys maybe heard the term diatomic, maybe, okay? That's fine, and that works for most of them. There's actually 9 molecular elements. 7 of them are diatomic, which means they come in 2 atoms, diatomic, of course. And that's fine, but what about P4 and S8? So a better term for that is what we call the molecular, which means molecules of atoms. So they've combined together, okay? So when you're walking down the street and you say, hey, look, it's oxygen, right there, you probably see 2 of them linked together because, well, we'll talk about that as we go along here. According to their diagrams, especially Lewis diagrams and things like that, they have 6 electrons in their valence shell, and they like to pair up and share to become more stable. Okay, so we'll talk about why that is and which ones pair up and things like that. A good indication of which ones pair up are the ones that you see here, of course, which are the molecular elements. I will ask you at some point in time, what are the 9 molecular elements? And you'll tell me iodine, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, phosphorus, and sulfur. And you should know how many of each one there is. Okay, how do you remember those? Well, you have a little thingamajigger there. That's called an synonym or an antonym or something like that. I teach chemistry, so I don't know. Hey, I use the same jokes. It's called a... Don't you guys know? It's an acronym. Come on. You should know. You're in grade 11. You guys have English. 3 of you do. Hey, I still don't know why. But you have acronym, is what it's called. That's how I remember them. I have no brighter, clever friends, people stupid. I came up with that by myself. That's a trademark, so don't try and copy it and don't try and patent pen it somewhere else. I don't care how you remember them, just you need to remember them, okay? That's what I use. I have no brighter, clever friends, people stupid. Some people say, well, look, it's iodine, bromine, chlorine, fluorine, so that's like group 17 there. And then you got your NO, no, and then PS. So that's kind of like a reverse flag. And then you got hydrogen way off to the side there. Some people do that. I don't care what you use, just know them, okay? This is something that, once again, like I talked about before, Unit 4, when we're doing chemical reactions, you have to know that oxygen comes in 2s and nitrogen comes in 2s, so that we can balance chemical equations correctly and so on and so on. Okay, so make sure you know those 9 molecular elements. All right, I'll let you guys copy here for a bit as well. Okay, so compounds are pure substances made up of 2 or more elements. Each type of compound has the different elements joined together in a certain fixed ratio. So we're going to talk about ionic ones like copper 2 sulfate, for example. We're going to talk about molecular ones such as nitrogen trioxide. Compounds can be broken apart. So elements, of course, you can't break those apart by decomposing. They're the simplest form. That's what you're going to find. If you wanted to take, for example, copper 2 sulfate and break it down, you could. You could heat it up. It would break down eventually into copper, into some sulfur, into some oxygen. And we'll actually do decomposition when we get to Unit 4 there. We're going to burn some stuff. We're going to heat up some stuff. It'll be cool. Burn it. Yeah. Heat it up. Actually, we wouldn't burn it because that's combustion. We're going to decompose stuff. It'll be fun. Okay, so... or by electrolysis, both of those are chemical processes. When you talk about mechanical mixtures, we talk about 2 different substances that are clearly visible. So the best analysis or best kind of scenario I can give you for that is if you think about water and oil. Okay, You know, when you look outside and it's raining out and you see the pile of oil that a car has left, and it's kind of sitting on top, or it's got that film on top of the water. All right. You can use processes to separate them by magnetism, flotation, and physical sorting. Another example I can give you of mechanical mixture, I guess, is when I was in university, my girlfriend, I know, hard to believe, maybe it's even a made-up story, who knows. Regardless, my girlfriend took me to this Italian place, and it had, you know, when you get the bread, you know what I'm talking about, olive oil and balsamic vinegar on top. You guys have had that? And you get the little pieces of bread and you can dip it in there and eat them. If you haven't had it, you should try it. Go get some olive oil, put it in a little cup, put the balsamic vinegar on top, and if you do it carefully, if you don't just dump it in, then you get the oil and you get the vinegar that sits on top, and it looks cool and it tastes good, especially with butter. And it looks, that's an example of mechanical mixture. We can clearly see the two different types there, okay? And if you haven't had that, find a girlfriend or a boyfriend to take you, I guess. You got time, okay, till prom. All right, no pressure. Solution, last one, I think. Mixture of substances which appear to be all the same. There's at least one solute and a solvent. So we're going to spend an entire unit on this, unit 3, okay? Solute is what we call the substance being dissolved. Solvent is the substance doing the dissolving. Water is the most common solvent, and we'll come back to this later on as well, but I thought I might as well throw it in there since we're talking about it. These types of solutions are called aqueous. And if we had an aqueous solution of copper 2 sulfate, aqueous is the water part, that's the solvent. Copper 2 sulfate is the solute. That's what we're putting into the solvent. All right. And we got a little bit more down at the bottom here that we'll show you in a second here, I guess. Okay, and there's the rest of the notes there. Water is the most common solvent. That's what we're going to use for our class here. These types of solutions, like I said, are aqueous. Substances can be separated by physical process such as evaporation or distillation. Okay. Once again, if you had an aqueous solution of copper 2 sulfate, copper 2 sulfate is what we would call the solute. That's what you're putting into the solvent. In this case, of course, water. All right.